Vectors represent an especially important type of data structure in R. Not only will you interact directly with vectors in nearly every R session, but they also form a basis for a number of the more complex data structures you'll use, including things like matrices, factors, and data frames. Technically, in this video, we'll deal with atomic vectors, but in our focus on more practical uses of R, that's not really an important distinction right now. As we go along, we'll talk about what constitutes a vector. We'll address two important aspects of working with vectors, vector recycling and indexing. And we'll also talk about attributes, which are a characteristic not only of vectors, but of other data structures in R too. Let's start by thinking of vectors simply as one-dimensional objects. For example, a string of numbers, or maybe a string of location data. An important point about vectors in R is that no matter how long a vector is, whether it has length 1 or a million, all of its individual elements have to be of the same type or class. For example, a vector can contain 100 numeric elements or 100 character elements, but it can't have a mixture of numerics and characters. Let's take a look at a few examples. The first is simply the number 5. This is a vector of length 1, and as you might guess, R would assign this vector to the class numeric. Next, we have cat, dog, cow. We can count up the elements to get the length 3, and in this case, R will assign this as a character vector. Our next vector, 1, 3, 5, 7, 9, has length 5 and is numeric. How about true, true, false, true, false? This also has length 5, and because it consists only of trues and falses, it's assigned to class logical. Finally, we have a slightly more complex vector. This one consists of a couple of colors, red and blue, several numbers, and also a true. Getting the length is still easy enough, just count up the elements to get 6. The class here is a little trickier though. As I mentioned earlier, all the elements of a vector have to be of the same class. In this case, R is going to assign this vector to the character class. You can think about classes as having something of a hierarchical structure, in which some classes are broader and more inclusive than other classes. For example, it's reasonable to think of the number 3 as a character, but it doesn't make sense to think of the letter A as a number. So we might say the character class is broader or more inclusive than numerics. Trues and falses are best considered logicals, but if they're combined with numerics, they can be treated as ones and zeros, and therefore easily converted to numerics. In this specific example, character is the least inclusive class possible that's appropriate for all of the elements in the vector, and so that's what the vector gets assigned as. Now, let's generate an initial vector. If we want to create a vector that has length 2 or more, we do that using the C, or combine function. The argument that is passed to this function, or in other words, what goes inside the parentheses, is typically a comma-separated list of the elements we want to combine into the vector. Here, I'm using this C function, along with the assignment operator, to create our first vector named oddvec, containing the values 1, 3, 5, 7, 9. Once it's created, you should see this object appear in the top right window, where you get a preview of the object. In this case, it's short enough that you can see it all, along with the class it's been assigned to, numeric, and also 1:5 in square brackets, which indicates the length of the vector. Once you've created your oddvec object, let's create a second object, evenvec, which is going to be the result of adding 1 to oddvec. After you create it, notice that evenvec contains the even numbers 2 through 10. R utilized an important feature called vector recycling to produce evenvec. Let's create a few more vectors to explore vector recycling a bit more. First, we'll use the rep, or repeat function, to create the vector longvec. The rep function requires 2 arguments, what you want to repeat, in this case 1, followed by the number of times you want to repeat it. So here we get a vector that consists of 12 ones. Next, we'll create a vector called recycledvec, which is the sum of longvec and evenvec. Notice when we run the code to create this object, we get a warning message. Before we move on, let's talk about this message briefly. R distinguishes between 2 types of messages, warnings and errors. Error messages mean that R simply wasn't able to do what you ask it to do. The code didn't run. In contrast, a warning, which we have here, means that R did do what you ask it to do. It ran the code, but it thinks you might not really be doing what you intend. In this case, the warning is that the longer object length is not a multiple of the shorter object length. Let's take a look at those two objects. LongVec has length 12, while EvenVec has length 5. When you try to perform an operation on vectors, like adding them together, the very first thing R does is to determine the lengths of each vector involved. And if they aren't the same, it recycles the shorter vector until they are the same. In this case, the 2, 4, 6, 8, 10 of EvenVec gets recycled one time, making it length 10. Then, because that's still shorter than 12, R starts to recycle it again. Once the 2 and 4 are added, it has now reached the length of the longer vector, 12, and the recycling stops. Now that the two vectors are the same length, the operation is performed by adding the elements in the first position of each vector together, then adding those in the second position, and so on, making the resulting vector the same length, 12. Vector recycling is one really important thing to understand as you move forward working in R. A second feature of vectors that's important to understand is how they're indexed. Indexing is just another word for subsetting, and in R, one common way it's done is by using the square brackets immediately after the name of the object you're indexing. Here are 3 examples of ways that our recycled vec object can be indexed. In the first, we put 3 inside the square brackets to pull out the third element of the vector. The second is an example of indexing a range, in this case, pulling out the 4th, 5th, 6th, 7th, and 8th elements. Finally, we can use the combine or C function to pull out individual elements in a specific order. Here I've extracted the 1st, 5th, 2nd, 9th, and 3rd elements in that order. Let's now play around with vector recycling and vector indexing just a bit more to start to see how those two features might be used as you analyze data. We'll create an object logical vec. To this, we'll assign the results of the expression recycled vec greater than or equal to 5. In this case, recycled vec is a vector of length 12, and 5 is also a vector of length 1. So the first thing R will do is take the shorter vector, the 5, and recycle it 12 times to create a vector of 12 5s. Then it performs the logical expression, asking whether the value in each position in recycled vec is greater than or equal to 5. This results in a logical vector of 12 trues or falses. Notice that for any position in recycled vec that is less than 5, the corresponding value in logical vec is false and true otherwise. Now, we can use this logical vector to index recycled vec. Doing so pulls out only the values in recycled vec for which the corresponding value in logical vec is true. We assign this result as a new vector object high values, which has length 9. It contains the 9 values in recycled vec that are greater than or equal to 5. Before we wrap up with this introduction to vectors, there's one more aspect of vectors I want to point out. It's possible to create named vectors in R. Now, of course, we've given a name to each of the vectors we've created to this point, as they're objects in R and all objects have a name. But named vectors are different. Creating a named vector means that names are given to the individual elements of the vector. For example, imagine you have a data set of counts for items that can be one of 3 shapes: stars, circles, or squares. Let's say there are 12 stars, 7 circles, and 13 squares. We could represent these data with a simple vector of the counts, as I've done here with a vector I'm calling shapes. This is similar to any other vectors we've created so far, but we can alternatively name each of the counts to indicate the shape they represent. One way to do this is to provide the names in the format name equals value when we construct the vector with the combine function. So star equals 12, circle equals 7, and square equals 13. I've wrapped each name in double quotes here, which tells R that they represent a character string. If there are no quotes, R would instead expect them to represent the names of objects that have been created. For example, an object named star. and when the object isn't found, an error would be returned. This behavior regarding quoting doesn't just apply to creating named vectors, but is instead a fairly general behavior in R. Names of objects are given without quotes, while strings of characters that don't indicate object names generally need to be quoted to be interpreted correctly. Now that we've created our named vector, let's take a look at it, especially in comparison to its counterpart that is not named. The basic shapes vector looks like vectors we've seen so far, but when we view the named shape vector, the names are returned along with the counts. Even though it looks a little different, nothing has really changed about the vector itself. If we check its class, we see it's still numeric, and we can perform any operations on this vector just like we could if it weren't a named vector. One way to think about the names we added is as metadata for the object. In R, such metadata are referred to as attributes of an object and can be viewed with the attributes function. Here, we see that our vector named vec indeed has a names attribute defined. We can see a more complete summary of this object with the command str, which stands for structure, and returns the underlying structure of a given object. Doing so, we see that this is a named numeric object of length 3, and that it contains a names attribute that itself consists of a character vector of length 3. This structure command can be especially useful when you start to work with more complex objects down the road. You'll routinely work with vectors in R. Hopefully, this video has helped you build an understanding of some of the basic properties of vectors, like their class and attributes, along with some important features of how R handles vectors, such as recycling and indexing. Those understandings will be critical for moving forward with your analyses, and also for starting to learn about some of the other types of data structures you'll work with, including both data frames and matrices. We'll start to take a look at matrices in the next video.